It's nice to see you all here. Thanks again for coming to the conference. We hope it's has been a valuable day. You'll have a valuable day tomorrow, and you'll take home some stuff that is really going to help you out in your day job. So I'm CR Oldham. I'm one of the platform engineers at SaltStack. I've been there since almost the beginning. I think I was part of the second group of hires. So it's been quite a roller coaster, heck of a ride, and I consider myself really fortunate to have been able to work for the company. I'll let Nicole introduce herself in a second. She used to be on the integrations team with me. Now she moved over to the core team. I sure miss her contributions, but the core team desperately needed her, and she's doing a great job there. We're going to talk about proxy minions today. Am I too loud? No. Okay. We're going to talk about proxy minions today. So yeah, there's some history here. Not long after I came to SaltStack, Tom came to me and said, I want to be able to control switches with Salt. Can you make that happen? And so the first thing I did was I wrote an execution module to just call out over SSH to, I don't even remember what it was a Juniper switch or something. And that worked fine, but as I got to thinking, I realized that if we could make a regular minion talk to those devices, and if we could treat it just like every other minion, then you could connect up a bunch of these and they'd become part of your infrastructure, just like all the servers you manage with Salt. So that's where that idea came from. It actually took a lot longer to make it happen because the minion was never really designed to control anything other than the machine it was running on. So we had to rearrange a bunch of code in order to make sure that when you run those commands, they actually go where they're supposed to go, as opposed to being executed right on the machine where that process is running. So in a standard Salt infrastructure, it looks like this. I'm sure you're all familiar with that. You've got a bunch of Salt minions talking to a Salt master. Bonus points to whoever can tell me what the thing on the top is. Yes, you win. If you have proxies, it looks like this. So down on the bottom, those little boxes represent switches or some other hardware that, for whatever reason, can't run a minion. Maybe there's not enough CPU on board, maybe there's not enough memory, maybe there's some kind of security thing going on where you don't really want to run a minion, you just want to be able to communicate with it. There's any one of a number of reasons why you might want to do that. Then in the middle, you've got machines that are powerful enough, normally would run a minion. You just run a proxy minion process for each device that you want to connect to. And then those proxy minions connect up to your Salt master, just like all the other minions in your infrastructure. There's not really any difference. The master doesn't see them any different other than the normal functions that you might call to tell if it was a different OS installed or grains information, that kind of thing. So here's some details. We've got one process per controlled device. This isn't really as big a deal as it sounds. It's about 40 megabytes per proxy process. So on a 4 gig machine, you can run somewhere around 100 proxies, maybe a few more. Proxies, and as far as being CPU bound, that really depends on what kind of device you're trying to control. If you're familiar with netconf, netconf is essentially XML over SSH. And XML can be kind of CPU intensive to process, especially if you're pulling in a lot of it. If you're just talking like over a REST interface, with simple JSON, it's probably not that big a deal, and CPU is not going to be an issue. Proxies are configured through Salt's pillar mechanism. So we'll see. I'm going to show you in just a second. Actually, this slide doesn't match this presentation. I'm just going to show the REST API. But in the original example, we have two controlled devices. One's a regular minion. We've got one with a REST API endpoint that emulates a server. We have one that's an SSH endpoint, also emulating some kind of a server. I did those examples that way on purpose because I wanted the concepts to map over to what folks might already be comfortable with in managing servers with Salt. So it's just a REST endpoint or an SSH endpoint that acts like a server. And these servers have very limited functionality. They can install and remove packages, they can start and stop services, they can report some basic information. The only part of this that's not here is I'm just not going to show the SSH endpoint today because I have something else I want to show you instead. And Nicole has some things she wants to talk about, and I don't want to steal her thunder. Okay, So let me just show you the pillar configuration really quick. Okay, so we've got a regular top file here, which I'm sure everybody's familiar with. And I had a bunch of these configured earlier, but the one we care about is a proxy with an ID of P8000, and that points off to a pillar file called proxy 8000. And if I show you that, it looks just like this. Just the keyword proxy, and in this case, we need an URL variable that points to the REST endpoint itself, and then every proxy needs a proxy type, because otherwise it doesn't know which modules to load to talk to whatever device that you're trying to control. So in this case, it's just called REST sample. No, the sample REST API in this example runs on port 8000. The proxy is just like a regular minion, so it's going to open connections on 4505 and 4506.
So where is this trying to connect to? To the switch or to the proxy?
This connects to the controlled device. In this case, it would be a switch, or we have a REST endpoint that I set up. Does that make sense?
And can be any port? Like, what if the switch only has the telnet port? Maybe it doesn't have SSH or...
So the configuration here, let's see, do I have that? Okay, so we also have an SSH example, and this is how you configure that. In this case, you just put the host name in, or the IP address, and then we needed a username and password for this particular endpoint. And
The other example you showed was basically HTTP port, right?
yes, that's correct. Yeah. Did I get your question answered? Okay. All right. Okay, so that's the pillar. Okay, so what do you want to do if you're going to create some of these? So at a minimum, you need a proxy module defined. I'll show you some code that looks that demonstrates that here in a minute. Proxy modules need the following functions. In that module, you have to define a ping. You need to define a virtual function and a shutdown. That's really all you need. Now, there's some new stuff that it's really handy to have. If you're able to define a function called initialize, that reports whether or not the proxy is initialized, then that helps avoid some spurious errors inside your logs that don't really matter. It's just that because of the way proxies have to be bootstrapped inside the Salt code, when grains get set up, there's a chicken and egg problem where we try to set up the grains, but the proxy module's not loaded yet. So if the proxy has to talk to a device to get its grains information, it's not there, so it's going to throw a stack trace because it can't load them. But then a little further on, we are able to load the grains, so the initialize function just helps prevent that error. And then an optional is you can actually put a grains function inside your proxy module if for some reason that's how you want to get your data. So that's really all you need. So let me show you what this looks like. All right, we have a bunch of these in here, and we're getting more all the time. Nicole's going to talk about some of the other proxies we have. So here's the REST sample. Yeah, that's fairly readable. Okay. So, okay, I also didn't mention the proxy-enabled variable. So for your proxy modules, they need this dunder variable, or else they won't get loaded. And that's to prevent loading proxy modules that cannot be loaded for that particular process. And this is just for this example. I've got a grains cache. I've got some details information. We're going to do some logging. And here's the virtual function. So in this case, there's nothing really to set up, and we don't really need anything. So we're just going to return true. And then you need an init. So in this init, we're going to set initialize to true. and we're going to store the URL that we need to connect with, and we're going to grab that out of the ops dictionary. And just to make our life easier, we're going to tack on / if it's not there. This is the initialized function I was telling you about with a little comment here. Since grains can be loaded in many different places, and some of those occur before the proxy can be initialized, then we return whether or not our initialization process has been called. And def ID, we don't really need this anymore, but it's here just as an example. Now, as far as grains are concerned, you can actually put a grains function in here, and when the proxy module starts up, it will call this function and retrieve the information and store it where grains go inside of the rest of Salt. So in this case, for the REST API, we're just grabbing whatever the info URL returns to us. And we're going to store that in a grains cache that's just local to this proxy module. I've been working on an integration with HP, and that's where I got this simple cache idea, because there's a couple of grains options that take about 30 seconds to return from some of their devices. So I didn't want to have to wait 30 seconds every single time we wanted grains. So I added this grains refresh function that you can call to dump that and retrieve them again. Let's see. And then here are all the other functions that you might want. Service start, service stop, restart. These all just map right over to REST calls into the proxy, into the REST sample. And then down here at the bottom, we have shutdown. In this case, we don't really have to do anything, but this is here in case like you need to close an SSH connection or some other connection you don't want to leave open. All right, so if we pop over here to, this is the front end to that REST API. It just shows you that there are some services here. Apache and Postgres are stopped. We've got a Red Bull service that's running. I'm sure he's always running. And a couple of packages, core utils. Hey, somebody laughed. That's good. Core utils and foobar. So I can say salt p8000 test.ping. Okay. Oh, I've got a bunch of logging turned on. Sorry about that. That's you don't normally see that in production, but here's the result. And so we just got it true. So I also have a regular minion here that returns true, and I can target them both if I want. Let's see, TWD and P8000. So I can treat them both just like I treat any other minion. So if I want to install a package, and again, every proxy doesn't need package management. I just wrote it in here as an example. It actually just takes anything. So we can say, I don't know, Vim. And we're going to install Vim 8.0 because 8.0 is going to be released soon. There we go. We get a comment back. It's installed. It's true. If I pop back over here to my web interface, you can see Vim's been installed. So. All right, so that gets us pretty far, but I think what's really interesting about the potential for proxies is in the idea of adaptive infrastructure, and we talk about that a lot because we have the event bus, we have reactors, we've got engines, we've got stuff that can consume this data that comes off the event bus. Well, you can do the same thing with your proxies, and so for this particular example, the REST sample, I wrote a beacon that watches for an outage condition, some nebulous outage condition. And when that outage occurs, then I have a reactor that catches that event and fixes the outage. So it's just like any other remediation process you might execute. Oh, we're out of disk space. Well, I'm just going to go run an SLS that's going to clean all my log files because I don't really need them. That kind of thing. So let me show you how that actually works in this example. At least it worked a few minutes ago when I tried it. Okay, so let's see, do I have a window with the event bus open here? I do not. So salt run state.event. Oh, wrong machine. Okay, so this is obviously a polling beacon, all right? So you can actually, this is actually a picture of the event bus that's running, and that polling beacon is basically saying, nope, there's no outage, there's no outage, there's no outage. So when I come over here to the web interface and I click simulate, then you can see it says, all of a sudden it says outage equal true. See if I can find that. Thank you. Yep, right there. Okay. And even though I clicked the button and it showed that it was that the outage needed to be fixed, it's all of a sudden back. And that's because the reactor kicked in and did what it needed to do to fix it. And then we see that there's no longer an outage. So it's kind of a fun, example of the reactor and how it can work without having to do anything. And that all works with proxies. It works with regular minions too, but the point I'm making is that proxies are just as powerful as regular minions. As long as your interface to the devices you're controlling is robust enough, you can do anything that you could do with a regular minion. So, okay. All right, so, oh yeah, this is yours now, I think. So Nicole's going to talk about some of the other proxies that we built, including one for ESXi.
Okay, can you guys hear me okay? Okay. Yeah, so Adobe commissioned some work from us to build a proxy minion for ESXi hosts. So if you guys are familiar with VMware, you're familiar with ESXi hosts. And so we built a proxy minion to kind of take care of some things that they wanted to set up via the proxy minions on their hosts without having to install a minion on it. So this is just an example of some of the things that we built into it. There's others, but some of the things that we built into is like configuring your core dump location, where your NTP servers are, enabling the NTP service on the host, setting up SSH, putting an SSH key on the host, things like that. So when we started this project, we wanted to base it off of the PyVMomi library, which is VMware's Python bindings to their API. And that was working really, really well, except then as we got further and further along on the task, we realized, oh, this library actually doesn't cover everything that Adobe needed. So we also made it depend on the ESX CLI, which is the command line tool that ESXi host uses. But one benefit of this extra dependency is that if we built in some functionality right there that says the ESX CLI _ CMD, which means like if we didn't build the actual salt command to do something that you wanted to on the host, you can just use that sort of like a command.run, but with the ESX CLI call. So I just wanted to show you sort of how that works. Let's see, I'm going to start the event run here. And this is just my master. Can you guys see that okay? Probably not. Okay. So like CR was saying, you can ping the host just like a minion. I have a local minion running here as well. And then if I wanted to get some information about this host, you can use, from the command line, you can use some different calls. So this here gets kind of like some grains information. It's from the host, so that you know what version you're running, things like that. So another example of the execution module side is we have a whole bunch of getters and setters in there. So if we wanted to know what the current core dump location or network config is, sorry. That is reaching out to the host, and it's returning some information about what its current config looks like. Now, from the command line, we can also set the core dump location. We'll just set it to this. We'll set it to 200, we'll say instead. Oh, no, sorry. I forgot you have to pass it this. We'll just change the dump IP here. And so that returned true, that it changed the configuration. So if we want to look at that again, make sure that it actually changed what we said. There it is right there at 200. So that's very useful. And then of course we also have some state information. And then I also wanted to show you how you can actually use the ESXCLI command to do the same thing, but with the sort of like command.run option. So we set the command string to the actual ESXCLI call, which is system core network get. And then we get some information there as well. Okay, so with states, let's look at what this state looks like. So I have a state here. It has a couple of different settings in it just to kind of demo what something would look like when you wanted to set up this type of a host. So here you can see we're setting up SSH. We're making sure that the service is running. We want the service policy set to automatic, and then we want to put this new SSH key down. Here's some core dump information to just set that up. We can configure syslog. There's all kinds of things that we can do. This is just the state that I'm going to run. So there's that. And then you just run states on proxy minions just like you would on a regular minion. And I named this conf. So let's run with this with test equals true first to see how this is going to change the system that I have. Oh, wait. Uh-oh.
Oh, stack trace.
Yeah. That's not good. Why is it stack tracing on test equals true? Well, I ran this morning and it didn't stack trace. Oh, let's see. Well, sorry about that, you guys. But normally when this isn't stack tracing, it looks like a regular state return where you can see the new and old changes. And then, what is already in the correct state, things like that. Let's see. It's frustrating. I ran this morning. So since those are failing, I'm not going to run this to show you that it worked, but, well, I guess I can comment some of those out. But, what was the other one, the NTP one?
I can't see from this angle.
Sorry. Okay, let's try that again. Oh, except there's 3 failed states. All right. Says I'm not authenticated. I'm gonna actually restart the proxy minion and see if that's what's going on. Sorry. All right, sorry you guys. I'm not sure why that's happening. That was working fine this morning, but Anyway, so we'll just run these other states that we know are working. So 2 have changed, and 1 is right there. So that's just to demonstrate that the proxy minion should have the same type of state output so that you can monitor what is going to be changing and what's going to stay the same. And then we can run it without test equals true, and it'll reset those variables. Sometimes the proxy minions take a little bit longer to return their state information than a regular one, but I'm not sure why that's happening. I'm sorry. But it just depends on how long it takes the proxy minion to connect, because it doesn't have that regular. Sorry, what? Mm-hmm. Mm-hmm. Yeah. Yeah, no, I'm not quite sure why that's happening. It was working yesterday and this morning, and I checked it a bunch of times. So maybe I'll try. But anyway, that's the basic idea. And then we also just wanted to talk about, or just at least show you, CR showed you a list before of just some of the other proxy minion modules that already exist in Salt that you can use, that are already available to use. So, and that was all I had. Do you have any more?
You want to hand me the thing?
Oh, yeah.
All right, one last thing I wanted to show you is what do you need to do to write execution modules and states that take advantage of a proxy. And I'll just show you some code here for that. Which one do I want? Yeah, all right. So for modules, we're working on this integration with HP. And it's kind of interesting. HP OneView provides a REST API that we're going to call out to. But it's kind of handy to be able to call those functions outside of a proxy. Let's say you've got a one-off, you just want to run the execution module, and you have all the authentication information, so let's just call it. So we wanted to write the execution module so that you could call them standalone, or you could call them from inside a proxy. So in order to do that, I wrote a decorator that is, oh, did I already pass it? Oh yeah, here it is. Proxy, there's two decorators in here. The first one's proxy OneView wrap. So that wraps this function and is able to ask the question, okay, am I running this from inside the proxy? And if I am, then I need to get all the information out of this dunder proxy variable, which gets injected to execution modules and states and runners and engines whenever you're running that process inside, when the process is running as a proxy. So that's where it needs to get its connection information. If it's not running in there, then we want to get that information from the command line. So that simplified writing this execution module significantly, because I could just wrap it in the decorator, and then I still have to include these arguments in case you do call it standalone. But otherwise, everything just kind of happens behind the scenes. So, let's see, yeah, this is the module. Fortunately, HP provided a really nice wrapper library for Python and the OneView REST API. So calling this stuff is pretty simple. If I go down here, if I just want to get all the servers that OneView knows about, then I just needed to call the library function and then return the results. So, but the other key issue is when you're going to write states and modules for proxies is the dunder proxy variable. that's where the connection information is stored. That's where you can actually keep some other important information that you might need elsewhere inside your modules. Oops, Salt Proxy. And you can see in the HP module, yeah, that's how that works in there. Very similar to what we did before. So we have documentation for this. We have a whole category in here on proxy minions. There actually is a walkthrough that will take you through setting up the same REST API, the sample REST API that I demonstrated just now. So you can try that out for yourself and see how it works. You can also do the SSH thing if you want. We have an SSH walkthrough. And yeah, and then all the other Dunder proxy rails, all that stuff is described in the documentation. There have been a few enhancements in 2016.3, which is coming out. In particular, we had some issues with grains that got corrected, and then we added the ability to have the grains function in the proxy module get called automatically, so you don't have to do that by hand. A few other things, those are all in the release notes. Yeah.
I fixed it. It's working now. If
Okay.
You want to see it.
Everybody wants to know, what was it?
I just restarted the proxy
Oh.
minion and now it's working. So
I bet the
I'm not
connection
sure.
timed out.
Yeah, probably. So, so down here I have it running in debug mode, so you can kind of watch things go through, and then it's working now. So sorry about that, everyone. But yeah.
So restarting the minion?
Restarting the proxy minion.
process.
Restarting the proxy.
Yeah.
Yeah.
ESXi can get a little bit anal about
Yeah.
that open connection, I think.
So, yeah, so there you go. Most of these are green because I just ran this to make sure it worked before. But yeah, so I re-enabled the states that I'd commented out before. And then here's some of the changes that just occurred on that last state run. So.
All right, questions? Yeah, go ahead.
What I got out of this was like how to make new proxy minions, but and maybe I'm just ignorant, but like I don't quite understand like how to get a proxy minion running on a host such that I can access my phone.
Oh, yeah, that'd be important. Okay. Okay, that's what it looks like. So we have a script called Salt Proxy. I guess I could make that even bigger. And you pass it the ID of the proxy that you're going to set up. So that ID has to match the entry in pillar, or else it can't get its configuration information. And then just, you don't need the -L debug. But that's how it knows. Then after you run that, in fact, I could probably demonstrate that. If I delete the key out, don't know why that's taken a while. There we go. So it treats it just like a minion. You can see I started the proxy, and now I've got that proxy's key in unaccepted. So before I can do anything, I have to accept it, -AY, or whatever you want to use. And then we can ping it again. Yeah, there you go. Did I get at your question? Absolutely. Okay, sure. Others? Go ahead. Dash L debug will do that, yeah. Yeah, or you can, actually I think you need dash D in order to make it a daemon. Otherwise it runs in the foreground, but you just don't get any information because it's not logging to the console, so. Okay.
So it's not treated like Salt Minion as a proper daemon on node and configured via something that's a salt, you actually have to kick it off every time?
No, you definitely can create an init script or a systemd service file for it if you want. The thing is that we need to know the proxy's ID when it starts, so we don't ship that service file by default. And we have a feature called the Proxy Wrangler, which isn't documented yet, which is going to let you configure that stuff inside a pillar and like lay out, okay, we've got, let's say I need proxies and I need 100 proxies and I've got 10 nodes that I want to run them on. I want you to farm these proxies out to these 10 nodes, make sure they stay running. If they die off, restart them, those kinds of things. So
You don't envision it being treated like a Salt Minion in the traditional sense, package and daemon on node, controlled by a proxy. You see it more as a Salt master doing the farming out of these processes.
Yeah, and the reason for that is at least Adobe has been kind enough to show us they have. It's hard to manage 200 or 300 of those that way. You need something else to help you with that, or else it just becomes a pain. I mean, Tim right here, I'll put Tim on the spot. Their folks are they've got a dash for loop to start them all up, and they have to track the PIDs and kill them all off if you have problems. It's a pain. So we're working on that part. Okay. Other questions? That's how the Proxy Wrangler works. Yeah.
So in terms of hardware examples, you were talking earlier about doing the switches. Is there anything particular that's unique about that, or?
Yeah, it depends on how you connect to the switch. Some older switches you'll need a serial port, but in general, not really. I mean, if you're connecting over SSH and you're not using anything like netconf, then you're going to have to write some parsing code. The NXOS module that we also wrote for Adobe, that's how that works. It just scrapes the SSH session and does what it needs to there, because that was actually the quickest way to do what we needed to do, and it was fairly performant.
Spec-like in that sense?
Yeah. Mm-hmm. A little bit more robust. Okay. Go ahead.
So to clarify, all execution and state modules have to be rewritten specific for this proxy module, and are they all contained in the same file, or are they able to be split out?
They can be split out. So, for example, like our package manager, you've got package providers. You can write a package provider for a proxy minion, and if you adhere to all the standards, then all the package commands will work without being rewritten. So just like how we delegate to yum or apt or whatever package manager, you can do the same thing for proxies, but you still have to write that code because we don't know how that device needs to handle its packages, or if you even want to call them that.
All those states actually properly farm out to another module.
Exactly. Yeah. So where there's enough abstraction, you don't have to do the rewrite. But if there's not, then there's just no way around it. You've got to talk to it somehow. Others? Go ahead.
You just use like a file.manage function to manage the system file on a switch? Like why wouldn't you just store it that way?
So in that case, depending on your switch, you can use file.managed, but you're going to have an endpoint inside the proxy module to tell it what to do with that file. Maybe it's like, many switches you do, you do a config on the command line and you put the config there, you're not really uploading the file, you're just kind of typing it into the terminal. So you could actually delegate that outside of file.manage and make file.manage do that work for you. But there has to be some glue code somewhere in there, and that goes in the proxy module. Some switches you don't, I mean, some switches have full SSH. You just need to drop a config file. So, that'd be easy to write. Anyone else? Yeah.
Enterprise interact the same way as it does any other minion?
Yeah, there is some special support for enterprise for proxy minions, just because they need to be shown a little bit differently. But yeah, they'll work just fine. Yeah, it'll work just fine. Okay, we'll call that a wrap then. Thanks very much for coming.